Comments, Lesson 8, Part 1, Arrays. And we're going to go into this thing. Hopefully you can hear me. And we're also going to have a gigabyte worth of data again. So up until now, we've talked about different things, different structures, and now we're going to be coming to structures that are a little bit more complex and more interesting. It's going to help us build some of our applications a little more robustly. Things that we're going to talk about today that are going to support arrays are the for each loop. Talk about that a little bit. That's somehow, for whatever reason, it's a boggle for some students to learn the for each loop. They don't like it. We're going to create a structure. We're going to talk about structs in C as well, right? It's a very common structure to use for C, no pun intended. We're going to talk about how you can accumulate totals in arrays. We're going to talk about the difference between direct access and indirect access of a table. We're going to try and do a table lookup. We're going to look at a list box, how we do things with array, and, of course, multi-dimensional arrays, right? So it's a little bit different than we've seen. And, again, it's not like you've never seen arrays before. If you're in this course, you've seen arrays. You've worked with them in other languages. You're probably working with them now in PHP and other things. The difference here in C# is the syntax. Please be aware the syntax is very particular about how we do arrays, okay? So this is what screws you up. So let's talk about single-dimensional stuff. Again, what is an array? It's a series of memory containers, if you will, that are linked somehow, right? They're linked by, there's an association, or if you want to talk about some kind of container that holds the array, they're associated with each other, each of these elements, right? And, of course, we have a subscript or index that indexes each array element, right? And, of course, we're using zero-based arrays, just like we did in other courses. So, again, zero-based array numbering. The lower subscript is 0 by default, and the upper subscript, depending on how far you want to go. Really, from this particular case, there really is no upper bound, if you think about it. Not that you should test that. I don't suggest you put in 1 million or anything like that, right, for your upper bounds for the array. That would just take forever. But really, now with the computers the way they are, they really can handle quite a range, right? Some terms. Here's an interesting array, right? We got Han Solo, Luke Skywalker, Leia Organa, Anakin Skywalker, Chewbacca. These are all elements of the array that are containers for some of these names, these strings. That's all they are, right? Personally, I think Qui-Gon Jinn had an untimely death, but that's just me, right? But the rest of these, I mean, if you notice, it's a name string array. But the great thing about using arrays is you want to kind of put together related data. So here's a group of Star Wars names. They're related, right? You don't want to use an array to put data in it that's not related, if possible. Otherwise, yes, it's a container, but what you want to try and do is, from a concept perspective, think about putting together arrays that are related, with related data inside of it. And if you notice, from an index perspective, we start at 0. Even though there's 10 elements, it goes from 0 to 9. Very, very simple and straightforward. Oh, one thing to notice is the square brackets. Arrays in C# need square brackets, not round parentheses, right? Rounded parentheses. And that's the difference. If you were to VB and some other languages, it's round parentheses. Here it's square brackets for C and C-style languages. Okay. So here's an example of a subscript. So we have a name string, and we have an index integer we're using as a subscript, and we're assigning the null string to it, right? Double quotes is the null string. You're saying this particular element is null, or nothing, right? You can make them constants. You can make them variables, right? Or numeric expressions. Be careful with the numeric expressions. Sometimes what happens is if you try and calculate things, and I'm not telling you can't do it, but try and keep your numeric expressions low. And I'm talking about very simple. If you're going to do a numeric expression, do it somewhere else, and then put the final integer or decimal into the array, right? If you do use a decimal, it will work. The problem is it'll round, right? So be careful because it's going to round to the nearest index, right? So again, what you want to try and do is you want to try and do your calculation somewhere else and then put your index into the array afterwards. That's better form, right? Just like, Hook said in the movie Hook, bad form, right? It's bad form to put in your calculations inside, your index. It looks ugly, all right? So we don't want you to program ugly, right? So do it somewhere else and then put it in here with another variable. So here's the general form of the array. I don't know why I'm doing that today. Anyways, but as long as you're entertained, you have a data type, and if you notice, you have to have these square brackets next to the data type, which is kind of weird, right? It basically says the data type, it's a data type array, whatever the data type is, right? So if it's an integer, int square brackets means integer array. That's what C# is going to interpret it as. This is a different thing that you might see in other languages, or even other C-style languages. C#, this is its bit of syntax here, right? Then you have the array name, and then it equals to, and usually what you want to do is you want to instantiate this new object based on the data type, array data type, right? So here's the data type and the number of elements. So if I put in a number of elements as 10, you have subscripts that could go from 0 to 9, right? Similarly, if you can do it this way. Now, the second example here, where it says data type, array name is equal to new data type, and then there's square brackets here that's with nothing inside of it, and then these squiggly brackets here, right, these braces, and the initial value list, you can do it that way too, right? So you can kind of list the values, right, which is also another common way of seeing it. The third example here is another way, right? These are all the same things. It kind of handles, the end result is the same, right? You can also put an access modifier at the beginning of the data type. So is it a public or private array, as an example, and the number of elements. Very, very simple. Please make sure you notice the form. Form is very important here because you will trip yourself up if you don't do it this way. Here's some examples. A string, name string is equal to new string of 25 elements from 0 to 24, right? A decimal, square brackets, it's a decimal array. That's how you read it. Balanced decimal, right? New decimal with 10 elements, and so on. Okay, pretty straightforward. One thing to note, if you don't know how many elements in the array, right, this is perfectly acceptable as well. The third line, which would be this, right? We know that we have an integer array, it's a numbers integer, and it's a new integer, square brackets, and there's a list. Well, this could be however big you make the list is how big the integer array will be declared, right? What happens if you add another element? Can you do that later on? Query. Yes.
I'm assuming there's a add something to an array, like, or you can specify, like, I don't know, something like
Yes. Yes, Jean-Luc.
As far as I understand from these arrays, if you cast it to a certain type, like, well, you can add stuff to an array as long as it doesn't exceed its set storage value. So if you have a decimal 10, you can fit up to 10, and you just do, like, whatever thing at index location 8.
Okay. But I'm talking about this example here, where you have accounting, marketing, human relations, or 1, 5, 12, 18, 20, one of those things. What if I wanted to add another value? Can I?
No, because you typecast it to hold only the number of items at the set location.
It's a good question, and I think what I want you to think about is ask yourself this question when you're doing it, because sometimes what happens is people get this thing in their head that they can start adding additional elements, right? And this is not like a list. It's different, right? Lists have different properties than arrays do, and collections have different properties than arrays do, all right? Slightly different. So just be careful. It may not come out exactly how you think they will. All right. And again, if we have a list of 10 names, this is a valid subscript. We can't do 2.5, obviously. So you'll round it, like we said. Here's for each loops. So again, for each, we've seen loops before. We've seen the for loop, and again, I encourage you to use your snippets that we talked about last week in our rare addendum to to this course, where I added an extra little thing there for you, snippets. Use snippets as much as you can to save yourself time when you're working with on projects. Okay, it saves you time. It gives you this stub, a command stub, if you will, or statement stub. And inside, you're going to have an area where you can kind of throw things together. But at least the format, the syntax will be intact, so you can use a structure like a for each loop properly, right? So again, here, for each loop data type, the element name inside of this array name. So a good example of this would be for item in items list, right? You want to make the array name a little bit more complex, and you want to make the element name less complex. You don't want to make them exactly identical, right? Like people do, except with lowercase or uppercase values. That's bad, right? Bad form, right? You have to make it so it's identifiable. And it's human readable. Okay, so what it does is it says I'm going to loop through however long the array is. It's kind of built in, this function for arrays. And I don't have to check the length of the array. I'm going to keep looping through, and every time I loop through, my element name is going to access the index of the next element. So, for example, if I have an array of 10, and the first one is Luke Skywalker as an example, which is array 0, array and whatever in brackets, the 0th subscript, then element name is going to be Luke Skywalker. That's going to be the actual value of that name itself. So it's going to loop 12 times, like we said. You can also make it so that it's got to be some data types. You've got to kind of cast it. So, for example, here in this example, it's for each string, one name string in name string. Kind of a bad example. I'm not really sure I like that. A name in name string might be better, right? So if you want to make it human readable to you, and then if you're another colleague looks at it again in the future, they go, okay, I understand what's happening here. Sometimes what I recommend that you do to clarify is put some comments around this, I mean, it does take another second when you're programming. And I'm being sarcastic here when I say it, but really, it might help you to remember what the hell you're doing when you use a for each. Sometimes you don't know why you're using it, and it helps you. It seems like a very straightforward element, but some people have issues with it later on. Structures. Well, we're kind of shooting through this today, right? Structures are kind of neat. So let's suppose we don't have classes, because right now we haven't talked about classes in object-oriented programming very much at all, right? But we still want to put together a set of different variables that are related together under one structure name. Example would be character, as in character sheet, right? That we did it for the exam, right? So we have a character, right? It's public or private from an accessor perspective, right? We have the name of the structure. And then you have this struct keyword. And then these elements in here should be public. If you make them private, they're not going to be accessible, which is a bad thing, right? So you need to keep it like this, right? Even though your structure can be private itself, the elements in here should be public, right? So that they're accessible to the outside world, right? So again, will be this. If I called it character and my first data type was an integer, and my first field was strength, right? Then I would say character.strength. That's how I would access it, just like you would access any other element from a class, right? So it's kind of a neat thing. And so instead of passing one element at a time, like if I'm passing a group of variables that are related, instead of passing them all individually, as an example, I can pass them together within a structure, which makes it a little bit more efficient. Here's some examples. Employee, right? So you have your last name, your first name, your social insurance number, your street, your city, your province, your postal code, all that stuff. And if you notice, there's different types of variables, different data types, right? So there's strings, there's a date time, and there's also an integer. That's okay, right? Here's a product, another example. Description, the ID, quantity, and the price, right? Different data types, same kind of thing. And then the last one, I think, is one we want to talk about, which is like this. Well, here's some sales detail, right? And in here we have a decimal array that has a sale decimal. Ooh. But if you notice here, I haven't defined how big this thing is, and you can't within a structure. This is a limitation of when you use arrays within a structure, you cannot define how big it is. Because an array, a structure, what you're doing is you're kind of putting together a blueprint in some ways, right? So I want to leave it empty. I want to leave it unstructured, if you will, right? Afterwards, we can access that element and recast how many elements, almost like we've already created the variable called sale decimal, but we haven't actually instantiated the array itself. And we need to instantiate that array outside of the structure. So that's something that you might see that might mess you up a little bit if you're going to use structures. So here's an example. An employee structure, right? Office employee. So the office employee has all the regular fields that are inside the structure. And again, yes?
So the structure can't define any of the actual data within the structure. You can only set the variables.
Data types.
You define. And
correct.
From there, you could use it and add stuff in.
Right. All it does is structure. It's almost like grouping together. It's better if it's a grouping of related data or variables that you want to put together and you want to handle together. So it increases human readability, right? And so you understand from a concept perspective. If you're looking at it from a business rules perspective, I can create business rules around the way I write my structures. All right. So if I want to talk about an employee, I don't necessarily need to use a class, although I recommend it, right? But you could have a structure inside of a class itself, right? If you wanted to get that complex, right? And the structure itself has these groupings of like variables, right? So here's an example of the product. See this fourth example here. We've defined a product, right? A product array, inventory product, right? And I'm saying, well, guess what? This inventory product is a new product, so a new structure of 100 elements. So you can actually create, once you create this structure, it's like creating your own little data type, your own custom data type, if you will, right? So you can have 100 structures that you're using here, and depending on what product is, what things are inside product, every one of them you can access their fields within those elements, right? It's almost like doing a quick way of doing multi-dimensional arrays in some ways, right? Because, inside the structure itself, you could have an array. So it's an array of arrays, and therefore it's multidimensional. Again, what you're doing here is you're trying to conceptualize. You're using human readable variable names and this element that we've created, this structure, if you will, to make it more ideal in terms of understanding what you're doing. Okay, here's some more examples. So office employee dot last name. Office employee dot hire date time, right? Warehouse employee dot last name. If you notice, warehouse employee and office employee are using the same structure, right? They both have the last name string, but they're different variables. Okay? There's widget product description, widget product quantity and price, inventory product, and if you notice with an index integer, you're going to access it's an array of inventory products or products, if you will, with each of them having a description string or a quantity integer or price. So you can get quite complex with a structure, and it can actually save you typing a lot of multi-dimensional arrays and trying to put containers together or variables together that are the same and trying to pass more than one thing at a time. So example would be going back to the exam, right? Which we talked about is we have this issue where you wanted to pass you create a structure, and it's, as an example, we might have created it in main form. We could have also created it on the program.cs file as a global structure, a global thing. Not a great way of thinking about it, but you could pass on this structure, the whole structure, down the line, right? Pass it on down to the next form and the next form, and all you're doing is passing one thing, the structure, right? You're not passing every single individual item because it's inside the structure. You're aligning, you're kind of assigning values to elements of the structure, and you're passing it down, right? More efficient than passing, each individual element. It's kind of ugly that way. Okay. And again, we talked about this, but I'll show you exactly how it's done. So here we've defined, here's a structure sales detail, and inside there's a sales decimal, but we haven't decided how big the sales decimal is. Here, outside of it, we established a number of elements in the array. Because what we're doing here is we're instantiating the array outside of after the structure's been declared. Okay, this is the way you do it. If you were to try to do this, if you move this here, new decimal 7 in here, it would give you an error. Okay, don't do that. That's just syntax we're talking about here. Yes?
The 7, that just, for the actual array size, it goes 0 to 6, right?
Correct. 0 to 6. All right. Using array elements for accumulators. So here we have a total decimal array as an example, right? And what we're going to say is we're going to say, well, our total decimal array element number 4, which is subscript 3, right? We are going to make it equal to a value of 10, right? As an example. Well, we can actually use this plus equal or plus plus that particular increment the way we normally do any other variable, okay? Not a bad way of doing it, especially if you have more than one variable that you're accumulating. So if you have a count integer, instead of you making only one count integer, you can have a count integer array if you're counting more than one object all at the same time, right? Especially if you're running it through a multi-dimensional, nested for loop or some other kinds of looping structure. And here's a code example of that. So total decimal, that's the total decimal array, plus equals sales decimal. All I'm doing is accumulating that in the structure. I'm doing it inside of an inside of a try catch loop, and I'm using an if statement for that. Okay, very, very simple. Another use for it. So when we debug array programs, the great thing is to look at this autos window. We're going to look at that in a bit when we do our example, right? Because what you can do in the autos window is you can see what each element in the array holds, which is kind of a great way to inspect the array, right? You want to inspect each of the elements to make sure that what you think you're supposed to get is what you're actually getting. Now, how many people actually use debugging at all so far? Good. Please, thank God, right? If you haven't done it already, start using it more often. It helps you solve your problems a little bit because you sit there and you say, console, by the way, console.writeline is not bad, a bad way of doing it. Even using message boxes are the easiest way as well, just like alerts in JavaScript or whatever, right? But sometimes that's not enough because there's too much going on behind the scenes, and you need to inspect each of the elements that you're working with to see that you're getting the right data. Because you might be, maybe there's no error, but it's not reacting in a certain way. Something's not working. You're not getting an actual error, a syntax error or some kind of problem. But it's another kind of error. The way you're thinking is the error, right? And you don't know what's happening. You've programmed your algorithm in a certain way. You're expecting certain results, and you're getting something totally different, right? Debugging is the way to go. And this is a good structure using the autos window. But you can turn that off and on the autos window when you're using arrays. Setting a breakpoint, looking inside the array by clicking that that expander, that plus little plus. Next to the actual array name. In this example, it's total integer. You expand the array, and you can see each of the sub-elements in the array and what the value is. Table lookup. All right. So here's some steps how we're going to do a table, right? And again, we're doing it now. We've got some of the elements we've talked about. We've got a structure. We've talked about that as well as other things, arrays. And this is one way of doing it, a table lookup, without having any kind of object-oriented programming in play, really, right? Ideally, again, if you're going to set up a complex structure, I recommend you go with using the use of classes, custom classes. That's the better way. But if you don't, and let's say, for example, some people have issues conceptually to abstract in their brain how to use classes, and they find structures a little bit easier or quicker, it's okay, right? It's still good form. It's not bad. All right. Again, 4 steps: establish a structure and declare an array of the structure. So here's my array. I'm kind of, what I'm doing is I'm simulating a table, right? I use the form load event handler to put the numbers in a table, right? So it only happens once. Now, this might be okay, but if I want to re-put them in, what event would I use on the form? I'm going to have to pick your brains this morning. I know some of you are like, I need coffee, right? Don't ask me these questions, Tom. You're recording. The activation, right? You want to listen to the activation event, right? When the form gets activated, to reload it, because sometimes loading it one time, this loads it only the first time. But if you need to reload the event again and again, every time that form opens, the activation is the way to go. If you did it in the load, it only does it once, right? So you compare the value that's entered with the value in the table to select the appropriate subscript. So you're doing this search. That's what you're doing. You're doing a table search. You're saying, here's what I'm looking for, and I'm searching through my table. There's different ways of doing that, and to find the element. And then I can change the value of the array if I need to. What's bad with this kind of structure? Yes? I'll show you in a second. I will show you. Just take it easy. You'll see. What's bad with this, though? This is kind of a linear way of doing it, right? I mean, problem with it is if I have a huge grouping of stuff, if I have to look for a huge table, right, it's going to take a long time, right? I need to use a searching algorithm, which we haven't really talked about and is out of scope for this course, right? Some kind of sorting and searching algorithm that we want to use. Now, some of this is handled by C# as it is, but when we're looking through a large table, we're going to do a table search, table lookup, right? What we want to do is we use a better structure, if you will, than what we're doing here, right? But this is the basic way to do it. You establish a structure, you declare an array, and then you use the structure as a virtual table. That's what you're doing, setting up a table to look through. Let's take a look. So here's an example, right? I have a number string, right, as an example, a group number string. So the group number is not sequential, right? I don't have 101, 102, 103. It goes 101, 103, 110, right? Because they're different group numbers for whatever reason, okay? And I want to look up and see, I don't know which index it is, if it's 0, 1, or 2, and I want to search for this 110. I'm looking for 110. And then what I want to do is, with 110, I want to look at the actual value that's in the next memory location here, and extract that value, because that's what I'm really looking for. I want to look it up here and tell me what the total decimal is for group 110, is what I'm asking. Okay? Different ways of approaching this. You don't have to do it with a structure. You can do it with multidimensional arrays. You can do it many different ways. Okay? This is just one way that you can do it with a structure. How does it work? You declare the structure. So here's our structure is called group, right? You have two variables. You have a string and an integer. The string is a group number string, and the integer is the total integer. So your group number was what we saw before, right? So here's the group number string right here, right? Two elements inside the structure, right? Almost key value pairs, if you will, right? What does this look like? A little bit better than a structure. Maybe a dictionary would be a better solution, right? In some ways, dictionary lookup, which is what we're doing here. I'm just saying, right? And then what you're doing is you initialize the group numbers. So because the structure is not, the group numbers are not sequential, so now what we're doing is we're initializing, we're kind of putting together this table, right? So now this could be done here manually, or it could be done that you're pulling information from a database. Because the database table might have a different group name for each of the rows, as an example, right? So here's all your rows, 101, 103, 110, and so on. And you're loading these inside this group number string that's part of the structure called group, right? Pretty straightforward. And then here you're in a while loop, and this is where it's bad, right? You're going to search through, right? You're going to keep checking every element until you find, the element that you're searching for. But again, this is a linear search methodology, right? This is great. If it's a short list, it's okay, right? If it's a large list or big database, bad. Don't do this, right? This is just showing you what you can do with a structure. It's not bad for small lists like this. It's okay. When you use larger lists, you need to probably things like sort, ascending or descending might help, right? If you're looking for a certain, you can find it a little quicker. And use different sorting and searching algorithms that are built into C# by the way, right? That'll, I remember when I was in school, we used this bubble sort, right? We had to write one, right, by hand, right? They didn't have it, at all. They didn't have these structures, these fancy dancy things you have built into C# now, right? We had to write our own searches and sorting algorithms, right? But similarly is what we're doing here. And you can also use the sorting and searching algorithm built into with a query of your database, which might be even better, right? Because a lot of, if you use structured query language, right, SQL has a way better way of searching if you're searching through a database than doing this, right? Much more efficient. But if you're not, and if you have to do things manually, here you go. List boxes and arrays. The thing with list boxes is you have this selected index. Yes. Did I cover that enough, or did you understand what I was doing?
No, there's two. If you're looking for the value of
Key value pairs.
in
Yeah.
array,
No.
the array can only store. It's not a key value pair within an array. So how does it? I don't understand how you're finding
Structure. So let's go back. That's a good question. So the structure has two elements, right? There's two data types. This is what I'm saying, right? The structure itself is a container, right? This container is called group, right? Inside group, you have two data types. You have a string and an integer, right? There is no key value pair, so to speak. But if I create an array of this structure called array group, right? And the array has each element of the array, right, has two data types, two variables that are linked to it, right? You have one that's called the group number, and the other one that's called the total integer. So in effect, you're building a key value pair relationship. That's what you're doing. But you're not doing it through a dictionary, you're doing it manually. Okay? Yes, it's ugly. Was that?
Why would you use this over a dictionary?
You would not. No. I'm showing you the reason why you'd want to use structure. This is one way they're showing you from a textbook way of doing things. I don't recommend it. I think there's better ways, but I'm going to show you that this is one way you can use structure. Other ways is grouping together, and I think this is better, grouping together like variables from a readability perspective to satisfy business rules. That's the better way to do it. That's why you're doing it, not because of this, right? Let's continue. You know what? Well, let's pause here for a coffee break. So that's a good thing. And then my data won't be so big. We did a bit of a survey this morning, and I apologize, but I'd rather cut it here short and stuff. I see some of you already glazing, and we'll get back to this in a bit.